Hello, week 2, another example of slope fields. We're looking at the equation dx dt is equal to x plus t, and we're going to use isoclines. So the idea is that we're going to think of places where the derivative of x is the same. The inclines are the same. Iso means the same. So let's look at x prime equal to 0 because it's easy. And so that means that x plus t is equal to 0, or x is minus t. So along this line, x is equal to minus t, and the derivative is 0. So the slopes are all horizontal. dx dt is 0 at every point along this isocline. Okay, wonderful. Let's look at another value for x prime. Let's look at x prime equal to, let's say, 1. Then x plus t is 1. X plus t is 1. And so that means that x is equal to 1 minus t. So for example, at this point here, where x is 1 and t is 0, x prime is 1. And again, along every other point along the line, x is equal to 1 minus t. The derivative of x with respect to t is going to be 1 at every point along there. Okay, let's try a slightly different value. Let's take x prime is equal to minus 1. Then that means that x plus t is minus 1, or that x is minus 1 minus t. So, for example, when t is 0, x is minus 1 here, and the slope is minus 1, right? X is like that, decreasing with t. Now, it's a little hard to draw because all this line is going to have slopes that are along that line. Let's do one more. Let's look at x prime is equal to 2. We get that x is equal to 2 minus t. And so when t is 0, x is 2. And the slope is 2. And that's true everywhere along this line. The slopes here are all 2. So let's imagine what a trajectory looks like. If, say, we start over here, then at first the value of x decreases, so but by less than 1, right? So we're decreasing a little bit, but not as quickly as t. So that looks maybe something like this. And then here t has gotten bigger and x has gotten smaller. So we're getting closer to a higher slope. Eventually we'll cross over and do something like this. Negative time, it'll look like this. What happens if we start along this line where x prime is equal to minus 1, then it will actually continue along here because x is decreasing by exactly the same as what t is increasing in. So the trajectory will actually be along that line. So that may be a little bit unusual in some ways. But if we continued on the other side here, we might have examined what happens to trajectories on the other side as well.